A fat hose pipe is held horizontally by a fireman. So initially the water is delivered with the speed of 1 liter per second in one particular direction. Okay, this is the initial speed of water delivered. Okay, next, suppose if by increasing the pressure, if he increase the pressure, the water is delivered at what speed? 2 liter per second. Means the speed is increases now from 1 liter per second to 2 liter per second. Then how much force has to apply by the fireman to hold the hose pipe? That is the question. They are asking how much force the fireman has to hold. So from the question explanation, what you understand? They are asking to find out what? Force. So I will write first force formula. F is equal to mass into acceleration, right? We know that force is equal to mass into acceleration. Again, I want to write a mass into velocity by time. Why? Because in the question they given speed at one particular direction. Means nothing but velocity, right? So here also. So I want to write acceleration as velocity by time. Okay. This is the actual formula I need to use here. But they given two cases, right? Initially 1 liter per second the water is delivering at one particular direction. And what is the second case? 2 liter per second in another direction. So I will take a case 1. What is the case 1? Velocity is 1 liter per second. Okay. And time is 1 second. This is the first case. Right? And what is the second case they ask? Case 2 is velocity is 2 liter per second and time is 1 second only, right? These are the two cases we need to solve now. Initial case. So we already know that the density is equal to, first I want to find out what mass, right? So mass, where I have to find out? I know density formula, density is equal to mass by volume. From this, mass is equal to density into volume, right? So density, I don't know what density it is, so I will keep it aside. Okay, next, into volume. Volume is 1 liter. So 1, that is equal to rho. So M is equal to rho in the first case. And second case, same as density is equal to mass by volume. From this, mass is equal to density into volume. So density rho into, what is the volume? 2 liters, right? So that is equal to 2 times of density. That is a mass in the second case. So this is the equation number 2 we got, right? So I have that mass is equal to rho in first case, and here in the second case mass is equal to 2 times of rho. So in this first case I want to calculate force, that is called F1 is equal to mass into velocity by time. Okay, what is the mass I got? Rho into, what is the velocity in the first case? 1 liter per second. So 1 divided by, what is the time again? 1 second. Yes, that is equal to rho. Therefore, F1 is equal to rho. This is the first, I applied force when the water delivers at the speed of 1 liter per second. And now I have to calculate what is the second force. When the speed of the water is changed from 1 liter per second to 2 liter per second, how much force I want to apply to hold that hose pipe. Okay, so F2 is equal to, what is the formula? Mass into velocity by time. Okay, yes, what is the mass I got now? 2 rho into, what is the velocity? 2 liter per second divided by time. Time is how much? 1 second only here also. Yes, that is equal to 4 times of rho. This is F2. So from this, what you understand? Force F2 is equal to 4 times of rho means F1. F1. Initially how much force you apply? No. Now we have to apply 4 times of that. Then only we can hold the hose pipe. So the answer is push forward 4 times hard. Thanks for watching.